Hello viewers on YouTube. In this video tutorial, we're going to focus on Soh Cah Toa. If this is your first time of hearing that kind of postulate, then you don't need to panic, because I'm going to disclose what it means in essence. Alright. Now, before we begin, I would like to branch trigonometry. Entirely out there, we have different types of functions. Functions works like something that change behavior of another thing. Take for instance a grinding machine. When you put a raw pepper into the grinding machine, what it does next is to blend it and turn it into a watery stuff. So that's what you can think of function that way. That's what function does. It receive an input, then convert it to something different, and then produce an output. So that's what function means in next sense. Now we have different functions in mathematics entirely. We have trigonometric functions, we have hyperbolic function, and a lot more. But in this video, we are going to branch trigonometric functions. The basic types of trigonometric functions are 6, but we have the first 3. Now these 3 functions are the sine function, S-I-N, the cosine function, COS, and the tan function or the tangent function. Right? Sometimes you might have this as COSINE, while this might be TAGNT, tangent function. Regardless, just keep in mind that for short you can have it as sine, cos, and tan. Perfect. Now, what these functions, what they do in next sense is that they help us to find the side of a right angle triangle given just one angle and one other side. Let me come again. These functions helps us to find the side of a right angle triangle given just one angle and one side of the right angle triangle. Now keep in mind, there are some other ways in which these functions can be of use, but in this video tutorial, we are only going to focus on how to use this function to find the side of the right angle triangle given one angle and one side of it. Now, how do they connect the side of a right angle triangle? This is what brought up the idea of Soh Cah Toa. So let's consider a right angle triangle. Oops. Let me do that again. I literally want to make it a little bit more straight. Okay, perfect. Okay, let's work with that. Now we know that from Pythagoras theorem, we're able to know that for any right angle triangle, the longest side of this triangle, which is typically this side, is called the hypotenuse, which is written for short as HYP. Now the opposite is the side that is standing vertically, or the side that is standing, just to say. That's OPP written for short, while the adjacent is the side that is facing the horizontal ground or that is on the horizontal ground. So which is typically the side ADJ, which is written for short as adjacent. Perfect. Now, why selecting the opposite, the adjacent, if you are using Pythagoras theorem, the formula doesn't really being affected. In fact, you can assume this is your opposite, while this is your adjacent. Regardless, the formula won't be affected, and you still have whatever you want as the right answer. But when it comes to functions, selecting the opposite and adjacent is very crucial. You have to be very careful, as it has a condition. For a side to be an opposite side using trig function, there's a condition that has to tell. Similarly, for a side to be an adjacent, there's a condition that has to tell. It's only the hypotenuse that remain unchanged. As long as it is the side facing the right angle triangle and it's the longest side, then it is the hypotenuse side. So how does this function? How do they connect the side of the right angle triangle? So here's how they connect. So for the sine, let me get it like this. The sine is equal to, if this is the angle theta, for instance, let's say we have the hypotenuse side to sustain an angle theta with the adjacent. So what function sine said was that sine theta is equal to the opposite divided by the hypotenuse, while cosine theta is such that it's equals to the adjacent divided by the hypotenuse, while the tan is such that is the ratio of the opposite to adjacent. Perfect. Now, this might be a little bit tricky for those that might be seeing it for the first time. Now, for easy remembrance, for easy recollection, how can we make this thing more simplicity? That is when the idea of Soh Cah Toa comes in. Now, since sine is such that it is opposite over hypotenuse, so they take the first letter of that function, the first letter of the numerator side and the first letter of the denominator side, and combine it and have SOH. So they repeat the same thing for the other function, CAH. That becomes Ka. And finally, for the last one, they have it as TOA, and that's simply Toa. And that's it. So the goal is just for you to keep in mind this postulate. Soh Cah Toa. The sine will be opposite of hypotenuse, cos will be adjacent over hypotenuse, tan will be opposite over adjacent. Now, the next thing I want you to know is that if this angle now tends to not be here, but instead here, what would happen? So let's see. So if the angle is there, what would happen now is that so if angle theta is now here, the opposite side has to be the side facing the given angle. Just like as the hypotenuse side is the side facing the right angle, the opposite side has to be the side facing the given angle. Now, if that angle is now here, that means you can't say this is your adjacent, but instead your opposite. I wish you get that. But instead your opposite. So now, what I will do instead is that let me assume this is alpha. Since we have used theta for this angle that is on the horizontal line, let's use that alpha for that one. Now, this will now become our opposite. So I'm using the pen for that, or red color. This is now the opposite, the new opposite, while this is now the new adjacent. ADJ. Perfect. So now, let's see how the functions connect the side again. So according to, or relative to sine alpha, we can see that to alpha to say sine alpha would be equals to opposite, which is this one right here, right? So that's opposite over hypotenuse. Perfect. Now, what else? Cosine alpha. Cosine alpha is also equal to what? Adjacent over hypotenuse. ADJ over hypotenuse. And finally, the tan of alpha equals opposite of adjacent, that's this side over this side. Perfect. So that's opposite over adjacent. So that's how it works. How it's together. So just make sure that you know the exact side that corresponds to the opposite side, and that will depend on where the angle falls to. If the angle is here, opposite will be here. If the angle is here, then opposite will be here. Now there's a relationship between these two formulas, but that won't be disclosed in this video. Right? That will be in our next video. But for now, let's just go over some examples on how to use this side to find the other side of a given triangle, given one angle and one side. So consider the right angle triangle. Whose hypotenuse is 5 centimeter and this angle is 30 degree. Find the value of y and x. So to find y, the goal is to find the function that connects this side and this side relative to the given angle. So what function is it? First, let's identify our opposites, adjacent, and hypotenuse. It's a right angle triangle. It's normally news that this is HYP. Now opposite depends on where the angle falls to. So y corresponds to opposite, OPP, and this is simply ADJ. Perfect. And this is how I would recommend you solve any kind of problem, so that your solution will be straightforward. So now, what function do you think will work best? Well, since sine of angle theta is opposite over hypotenuse, this function will definitely help us out, because it has all what is given, likewise what we can solve for. So therefore, we have the sine of 30 to be equals to opposite y divided by hypotenuse 5. Upon cross multiplication, y becomes 5 sine 30. Sine 30 to be translated into your calculator, that gives us 0.5 or 1/2. And finally, y will be 5 divided by 2. That makes sense. That gives us 2.5. It won't be up to the hypotenuse because the hypotenuse has to be the longest, which implies that it has to have the highest magnitude. So that's the side of the opposite centimeter. Now, what about the adjacent? What function do you think will help us out? Well, since we know that the cosine function of the angle theta is equal to the adjacent divided by the hypotenuse. Now, since cosine function has all the criteria, we are good to use it. So therefore, the cosine of 30 will be equals to the adjacent x divided by hypotenuse 5. Upon cross multiplication, just like before, we have x to be equals to 5 cosine 30. Now, if you type in cosine 30 using your calculator, you have 0.866. Then I have x to be equals to 5 times 0.866. And if I multiply 5 with 0.866, I got 4.33. So that's 4.33 centimeter. So that's our adjacent for this triangle. And that's how to easily make use of the trigonometric functions effectively. Now keep in mind, since you have the opposite earlier to be 2.5, you can use the tan function instead of as opposed to the cosine function to find the adjacent. At the end of the day, you have the same results. Let's confirm that. We said the tan is equal to, or the tan of 30 of theta is equal to the opposite by adjacent. Now, since the goal is to find x, then that means tan 30 will be equals to 2.5, which is the opposite, divided by x. Now, if we cross multiply, we'll end up having x to be equals to 2.5 divided by tan 30. So let's confirm that. So when I type 2.5 divided by the tan of 30, you will observe that we end up with the same result. So I end up having 4.15. 4.15. Well, that becomes 4.12 approximately, and 4.12 and 4.2 and 4.3 are very, very close. So that's it. The answer will be very close, or sometimes, most times, it will be exactly the same thing. Right? This might be probably because the question was formed offhand. Perfect. So that's how to easily make use of the trigonometric functions to solve the sides of a right angle triangle. So thanks for watching. This is your exercise. Feel free to share your solution via the comment section below. Consider this given right angle triangle. Find the missing side. $70 degree, then we have 4 centimeters. So find the value of x and y. Feel free to share your solution if you have a comment section below. Thanks for watching once again. Bye for now.